Welcome everyone. So we're going to keep talking about logarithmic functions. Specifically, we're going to look at properties of logarithmic functions. So let's get right to it. All right, so we're talking about properties now of logarithmic functions. And just like before, we're going to see some nice parallels with the exponential functions, and particularly our rules of exponents. That's going to really come up when we start looking at the proofs of these properties. So what are the properties? Well, I've got three here that I want to look at, and these are first three we're going to see. That we're going to add one more shortly. The first says log base b of a times b is the sum of the logs. So the log of a product is the sum of the logs. And if you think about exponents, what do you do with the exponents when you're multiplying? Well, you add the exponents. And doesn't the log function essentially tell you the value of the exponent? Well, that's where this comes from. Similarly, the log of a quotient is a difference of the logs. And then if I have a log of a power, I can take that power and make it a factor or a factor in the product of c times the log, which again, if you think about exponents, a power to a power, you multiply the exponents, right? Well, that's what we see with property 3. So let's go through and prove these, and I'm going to start with the first one, okay? And so what I'm going to do is I'm going to define some terms. I'm going to let x be log base b of a, and I'm going to let y be log base b of capital B, okay? Well, what does that mean? Well, this essentially means that b to the x is equal to a, and b to the y is equal to this capital B. Okay. And so let's see what happens with our product. Log base b of ab equals, well, log base b of, what did we say b was? Oh, b to the x. And what did we say y was? Oh, b to the y, which is log base b of b to the x plus y. And that's just what? Well, log base b of b to some power is just that power, x plus y. And what did we say x was? Oh yeah, log base b of a, and y log base b of b, okay? So that's property 1. How about property 2? Well, we have log base b of a times b. And what I'm going to do is I'm going to rewrite this. This may even seem like, I'm sorry, not ab, I have law 2. So we have a over b. Sorry guys, log base b of a over b. And so I'm going to do something that might seem like cheating, but it's not. It's perfectly legal. I have a over b. Sorry, got myself in circles here. Let me rewrite what I'm trying to prove, right? Log base b of a minus log base b of b. That's what I'm trying to prove, okay? And so I'm on a new page here, I'll just remind you. Okay, so what I'm going to do is I'm going to do something that might seem like cheating, but it's not. So I can rewrite a as a over b times b, right? Right, b's cancel, so I just get a again. But what does this do? Well, this lets me take advantage of law 1, the previous property, and it lets me say log base b of a over b plus log base b of b. Well, if I subtract log base b of b from both sides, right? I'm just going to subtract that term right there. I get exactly the property that I'm trying to prove. Okay. Again, seems like a cheap shot, but it's not. All right. And then for 3, I'm going to define a term. I'm going to say, again, I'm going to let x equal log base b of a, so that b to the x is equal to a. Okay. And so then I can come down here, get my hands on what I'm trying to prove. This is going to be log base b. Well, we just said a was b to the x, right? So b to the x to the c, which is log base b of b to the xc. And we just got done saying that if you have, in the previous lecture, if you have log base b of b to some power, that's just equal to that power, right? But what did we say x was? Oh, log base b of a. And so that proves property 3. All right? So let's practice these by evaluating some of these expressions. So a, log 2 plus 2 log 10 plus log 5. And of course, the base here is 10 because it's not marked. And so we know that we just assume that to be the common log. So log 2, I'm going to use these properties, plus log, well, 2 log 10 becomes log of 10 squared, and then plus log 5. Okay, well, log 2 plus log 10 squared plus log 5. I can bring this all together as a product. Okay. So I get log of, well, what's 10 times 100? I just wrote 10 squared as 100. That's 1,000. And 10 to what power is 1,000? 3. Okay. How about B? Log base 3 of 135 minus log base 3 of 15. Well, this will be log base 3 of 135 divided by 15. And what is 135 divided by 15? That's right, everybody. It's 9. So it's log base 3 of 9. Oh, it's just 2. Okay, let's use these to expand. Okay. So for A, I have xy cubed over z squared. And so what I'm going to do is I'm going to think about order of operations, right? You've got this numerator, you've got this denominator, right? And you're dividing them. So I'm going to start by dealing with the quotient. Okay. And then I can keep going, right? I have a product for my first log, so I can write it as log x plus log y cubed minus log z squared. And is there anything else we could do? Well, there is, right? I can bring exponents out front as coefficients. Okay? So there's A. Let's try B. Well, again, I'm going to do this. And then I'm going to consider the product. So root x plus log z squared minus log y. And then remember, square root is really a 1/2 power. So I can write 1/2 log x plus 2 log z minus log y. Okay? So we have expanded. Well, if we can expand, we can also condense or write as a single expression. So let's look at this. Our goal here is to write this expression as one single log, which we should expect to be able to do because we have sums and differences of these logs, and they're all the same base, okay? So what I want to do first is bring things in that can come in together. So I've got log x squared, and then this 1/5 becomes an exponent, and this 3 also becomes an exponent. And now I've got addition here. So I have a product. And then I'm subtracting, so this becomes a quotient. Okay. There we go. Let's try B. Oh, I'm sorry. Might help to have the same bases. Let's tell you what, let me change colors here. Let's make this ln and ln. Okay, so they're all log base e's, natural logs. So I'll rewrite it here. So we have natural log of y over x plus 2 natural log of x minus natural log of x y squared. Okay. So we've got natural log y over x plus natural log x squared minus natural log xy squared, which equals, and then I've got a product because I'm summing. So y over x times x squared, and then my denominator will be x y squared. Okay. And now it's just a matter of cleaning things up, right? So I got, well, x squared over x squared, right? So x squareds are gone. And I've got y over y squared. So I wind up with natural log of 1 over y, okay? Which, if I want to really think about it, natural log of 1 is 0, right? So I really have negative natural log of y, okay? Okay, so now the last piece here. This is going to be really practical. Remember way back when we started our discussion of exponential functions, I think we were talking about money, and I was saying, okay, you have these formulas for compounding interest, and it's easy enough to plug in a value for time and figure out how much money you've got. But what if we wanted to go the other way, right? What if we wanted to say, after how much time will I have a certain amount of money? Or if we're looking at viral growth, bacterial growth, after how many hours or minutes or days will the number of bacteria in my body be such and such? So we're trying to get our hands on the exponent value. We have a way to do that now. But what happens is, well, let's see. I have 2 to the x equals 5. And so if I rewrite this in logarithmic form, I get x equals log base 2 of 5. Now, this is what's called an exact answer. But as a mathematician, I love exact answers. But if I were in some applied field where I needed to actually do something with a number, this exact answer doesn't do much for me. I need it to be evaluated and rounded to some number of decimal places according to however accurate I need to be, but I need to have my hands on that. This doesn't do that for me. And on a calculator, Most calculators only have the log button and the natural log button. This is log base 2. What do? That's right, we throw our hands up in the air, close our books, and march off saying, can go no further. I'm kidding. Okay, let's see. We have this change of base formula, okay, which is very, very useful because it says that log base b of x is log base a of x over log base a of b. And that a can be any base, any base. So if I'm looking at my calculator, I can use log base e or log base 10. All right, well, let's prove this, okay, and see what happens. So what I'm gonna do is, let's, you know what? Maybe I'm gonna have you pause it. So why don't you guys go ahead and try to see if you can come up with the proof. Give it a pause, and then we'll see what we get. All right. So let's start with this expression. Y is log base b of x. Now I could rewrite this in exponential form, and now we get b to the y equals x. Now what I'm going to do is I'm going to take the log of log base a of both sides. Okay, so I have log base a b to the y equals log base a of x. Well, what can I do with this exponent of y? That's right, it becomes y log base a b equals log base ax. And so if I divide both sides by log base a of b, get this. Oh yeah, what was y? That's my log base b of x. Whoops, that was supposed to be a b right there. Okay. So there we have the change of base formula. Which means when I come to log base 2 of 5, I can take this and write it as log 5 over log 2. And why did I choose that log? Because it's on my calculator, that's why. And then literally plug that in. So grab your calculator and let's look at, well, log 5 divided by log 2. And we get 2.3219. Hey, just for kicks, what's ln 5 over ln 2? Well, ln 5 over ln 2. Hey, what do you know? You get the same thing. So again, the change of base formula is all about the fact we can use any base we want. Why do I use base 10 or base E? One simple answer, very practical answer. Those are the only logarithms on my calculator, okay? All right. So we are just about ready now to start solving exponential and logarithmic equations. Remember, those functions are inverses of each other, and so that opens up a whole world of equation solving, isolating the variables. So that's where we're going to go next. But just as a word of caution, you're not going to be very successful unless you've got these logarithmic laws down pat. So get your hands dirty with these, right? Get in there and work some problems. The more tedious, the better. Some of them will be long and tedious, but you want them to become second in nature. Because again, the big goal here is solving equations, and that's where we're going next. All right, so I wish you great studies, and we'll see you all in the next lecture.